Now you must have already studied that what is logarithm and what are the basic properties of a logarithm. So we will not need any basic properties, but you must know the basic definition of logarithm and the base changing formula for what I'm going to teach now. So write down logarithmic function. Now logarithmic functions is if y is equal to or fx is equal to log of x to the base a. This is the logarithmic function with the base is equal to a, and when this base is equal to e, this will be written as y is equal to fx is equal to ln x when the base is equal to e, right? And whenever this base is equal to 10, this function will be written as y is equal to fx is equal to log x to the base 10, and we don't need to write this 10, so this will just be written as y is equal to log x. So when no base is written, this is self-explanatory that the base is equal to 10. Now guys, the main thing which you need to note here is that this log function and the exponential functions are just inverse of each other. Now I'll not tell you the meaning of inverse function right now, you'll get confused, but just try to understand. If you apply the definition of log here, log x to the power x to the base a, here x will be equal to a to the power y. So this is nothing but the inverse of y is equal to a to the power x. So we can say that exponential function and the logarithmic functions are actually the inverse functions of each other. So just keep that in mind. We'll get to that when we study the inverse function later on. So this is the basic idea of logarithmic functions. Now guys, we've already discussed what are the possible values of x here. Now the possible values of x will define the domain of this function. Now the domain of this function is always R positive, all positive real numbers. Now 0 cannot come here. Log 0 is not defined. Okay, log 0 is not defined. So domain will be equal to all real positive real numbers. Guys, what is the value of log 1? Log 1 to the base anything, that will be equal to 0 always. So therefore this domain is R positive. Let's see what is the range. Now the range for this is all real numbers. How is the range all real numbers? I'll discuss. But first of all, let's see the restrictions on the base which is a in this case. Now restrictions on base is that it can attain all the positive real values except 1. Now why can't it attain a is equal to 1? Because fx is equal to log x to the base a can be written as log x upon log a by the base changing formula. If the value of a is equal to 1, fx will become not defined. Fx will become not defined. Therefore the value will be not defined in this case. So we cannot say that the function is defined. Therefore the value of base can never be equal to 1.